Hello, everybody, and welcome to Precisely's demo showcase today, where we're going to be talking about taking your legacy data beyond modernization with AWS and Precisely. My name is Brittany Schultz. I'm a product marketing manager here at Precisely, and I'm joined by the lovely Rochelle Grubbs and Gagan Gupta today, who are going to be helping us out with the demo, as well as a more technical panel discussion towards the end of the session. But before we jump into it, let's just start with a few housekeeping items. As far as webinar audio goes, today's webcast audio is going to be streamed through your computer speakers. If you have any technical issues with the web interface or audio, please refresh your page or reach out to us using the Q&A box and we'll try and help you out. Questions are welcome during this session, so please feel free to submit your questions at any time during the presentation using the Q&A box. If we aren't able to get to your question during the hour, we'll follow up with you via email. As far as recording and slides go, this webinar is being recorded, so you'll receive an email following the webinar with a link to both the recording and slides, and you can feel free to share that among your colleagues. And finally, for resources, you can check out our resource center in the user interface for additional content. And without further ado, let's get into it. So why modernize? IT ecosystems, the tools within them, and what it takes to manage them successfully becomes more complex every single day. Modernizing these environments can be both a lengthy and costly process. So why are organizations looking to spend so much time and money doing so? Well, we at Precisely find that organizations are never really looking to modernize just because. Often their data modernization efforts are coming from three core business use cases, and those are what you see here. So driving operational efficiency, enhancing customer experience, and delivering a foundation for AI and analytics. Now, both Precisely and AWS can be instrumental tools in modernization, but for the purposes of today's session, we're going to just focus on how bringing legacy data into AWS by leveraging Precisely's data integration capabilities can help you provide a better customer experience. So let's take a step back and talk about how the customer experience and their expectations has changed over time. Since the pandemic, both market conditions and technologies have evolved significantly, which has led to shifts in customer buying behavior and habits and how they interact with brands in general. To deliver an exceptional customer experience, it's essential to grasp the essential motivations behind what your customers' behaviors are. And our research indicates that consumers now expect this level of understanding from all brands that they choose to engage with. According to PwC, nearly 80% of American consumers point to speed, convenience, knowledgeable help, and friendly service as the most important elements of a positive customer experience. And consumers have a limited number of interactions with your brand, so that makes it crucial for you to maximize the value of every one. Even a single negative experience can significantly affect your customer base. About 17% of customers, so almost 1 in 5, will disengage after just one bad encounter. And this figure rises to about 59% after multiple negative experiences. So the cost of customer churn is extremely steep. Acquiring new customers can typically be more expensive than retaining those that you already have. So losing engaged customers can end up costing your business twice as much, which highlights the importance of fostering these strong, positive relationships with your consumers. And customers can label their experiences as negative for various reasons, and speed is often a significant factor. Today's consumers expect real-time interactions and responses with your brand. And research shows us that delays in customer initiation and then confirmation of an action, for example, waiting to see account information on a mobile app, can lead to a 20% drop in digital traffic, potentially resulting in up to losses of $400 million over time. So it's pretty significant. And beyond quick response times, customers are also anticipating personalized interactions with brands. McKinsey reports that 71% of customers expect personalization, and then 76% feel frustrated if they don't receive it. So this frustration can again lead to customer churn, which, as we've mentioned, can be really costly for your business. So in order to deliver an exceptional customer experience, organizations need to be able to seamlessly access all of their relevant customer and company data. However, accessing all of this relevant data is typically easier said than done. The reality of today's digital landscape is that your organization is often managing data across a complex mix of cloud offerings, on-premises platforms, and mainframe or mid-range systems. And if you're not doing so already, you're probably in the process of planning to do so. Gartner found that 81% of the respondents to their cloud and user behavioral survey used multiple clouds. And Microsoft found that 86% of respondents to their surveys plan to increase the spending on hybrid or multi-cloud infrastructure in the coming years. So these hybrid multi-cloud environments present new opportunities, but also unique challenges for delivering superior customer experience, which makes it both crucial and often difficult to achieve. And the limitations of traditional pipelines can make it much harder to address these customer needs. Often data is owned by IT, and more we see business users wanting to get access to it. Often there are massively loosely integrated solutions, so it's hard to move data through the business. And when you are doing so, it can be done in a slow batch ETL process. Often there are resource intensive data processing needs, and depending on what kind of systems you're using or what platforms exist in your IT environment, some of them can have monolithic design because they've been around for decades and decades. And finally, you have separate business and IT metadata. So it can be difficult to be able to track things like lineage or who's using what data. So in order to have a solution that meets customer demand, something that is successful and can provide a better customer experience, there are a couple things that you want to make sure are present in your solution. First thing is you want resilient and fault-tolerant replication, so you can ensure that you are able to have consistency across your network, even if there are network failures. You want a solution that is both scalable and performant so that it can operate at the needs of your business, and whether there are spikes or not, it can still adjust to that. You want a solution where you can design your pipelines once and deploy them anywhere. And finally, you want to be able to have that data when and where you need it so that you can, again, provide that personalized customer experience. So now that we've discussed what the elements of a successful integration solution looks like, let's bring it into a more real-world context. In this example, we're going to be looking at a national retail bank, and their goal is to increase sales and profits while improving their customers' digital experience. They're looking to bring in new streams of revenue while also providing flexibility that customers expect in today's market. For their desired end state, they want to ensure that the bank's digital experience is consistent across all customer channels. So whether that be in the branch, on the website, on the app, or when calling into a help center. Also, the account holder should be able to make updates on their own timeline and be able to see the results in real time. So it's not like they're trying to get a new account on Friday and they only see changes reflected on Saturday. It's real-time changes. Currently, the customer's information is existing within their data warehouse, which for the purposes of this example is going to be Snowflake on AWS, and the data is delivered there via Confluent. And the bank system of record lives on their IBMI system. So the solution is to leverage CDC capabilities to replicate data across these platforms in real time. Now I'm going to turn it over to Rochelle, who's going to take us through how the bank would address this use case, leveraging Precisely technology.
Hi, my name is Rochelle Grubbs, and today we're going to take a look at how the Precisely Data Integrity Suite is going to help us provide our bank an improved digital experience. Here you can see the Data Integrity Suite homepage. On the homepage, we can see a variety of different services that we have to choose from. All of the services interoperate and can help you provide your customer accurate, consistent, and contextual data for your business. So first, to get things set up, we're going to go over here to the configuration screen. On configuration, we'll take a look at the replication connections. We're going to set up a replication connection so that we can read our source and write to our target. In this example, we'll be using a source data from IBMI and target data from Confluent Kafka running on AWS. So if I click here on the three dots and choose Edit, we can take a look at the Properties window used to configure our replication connection. I'll hit cancel here. We can also do the same thing for our Confluent connection. If we edit, we can see all of the properties used to set up that connection. Now with our connection set, we're going to move on to the integration service and set up our integration pipeline in order to capture our changes from our source data. So if we click here on the project, and then inside the project, we can see three dots, click on Edit, and now we can start configuring our project. Inside the project, we have an intuitive wizard, which will walk through and set up all of the different options. We can choose our replication options, which controls what happens when we have errors or collisions, as well as copy options. I've got those all set up, so we'll just simply hit Next. Next, we can see our source and our target information. On here, we also have the option to catalog our metadata. Our metadata has already been cataloged. We can see that we have 6 libraries cataloged already. Once the metadata is cataloged, we can use that cataloged metadata across all of the services of the suite. So we don't need to do anything here. We can expand our target options, and we can pick and choose how we want our messages written into the Confluent Cloud topic. Here we can choose our message format. We have the choice of Avro, CSV, or JSON. I'm using CSV in this example, but you could choose any of those different options. Click Next, and we'll see our libraries that we have on the IBM I. We'll click here on this library, and we'll see our tables. And lastly, click on the table, and we can see all of the fields that we have to choose from. Next, one more time, and we'll see our topics. I'm putting all of the data into a single topic, but you could choose to have multiple topics in your application, whatever makes the most sense. Next, one last time, and we can see all of the different options. All of the changes that we've configured can be staged. We can pick and choose how we want that to happen. We can make them active and then restart the pipeline. So once the changes have been implemented, everything restarts. We don't need to do any of that because we already have our pipeline running. So I'll just simply hit cancel here and go back to the health screen. On the health screen, you can see that everything is okay and there's no action required, and our pipeline is in excellent health. Click on the pipeline name, and we click on Datasets, and now we can see the number of rows that have been captured. If I pull down the drop-down, we can see the detail of those rows. So we can see that 1,018 rows have been inserted, 4 have been updated, and 6 have been deleted. So now that we see all of our data, and we can see how many rows have been inserted and updated and deleted, now we're going to turn our attention to our application. If we take a look at the database tables that are powering our application, we can do that here from our SQL screen. If we take a look at our customer table, we can see that we have a number of customers. So if I select the customers, we can see all of our customers here that are listed in the customer table. Maureen Winters is our customer that is working today, and she's sitting in front of a digital application on a browser and has chosen to open up a new account and is working away while we're talking. If we take a look at the services, then we can see the different services the bank has to offer. Today, we'll be focused in on the top 3. Maureen happens to have a savings and a CD, and right now she's using the digital experience that the bank offers to open up a checking account. If we look at the accounts that exist today, we can see that Maureen has a CD as well as a savings account. So customer number 1 has both a savings account and a CD, indicated by the service type 1 and service type 3. Now, when she finishes entering all the information and opening her checking account, what will happen is the application will add another record to our table that contains all of the accounts that the bank's customers have. She just hit enter. So when she hits enter, that's going to add a record to our table. So now if we take a look at the records that are in this table, we can see that lo and behold, we had an additional record that has been added to this table. So customer 1, in addition to the service type 1 and 3 for savings and CD, now customer 1 has a service type 2, which is a checking account. Now, if we go over to Confluent Cloud, you may recall from our pipeline, we were replicating data from our IBMI system and writing that data to Confluent Cloud running on AWS. And our topic is showing here. And if we look on the screen, we can see that our record has already been updated and is written to our topic. And if I click on that data, we can see that customer 1, service type 2, and all the rest of the information about that account that she opened is already sitting in our topic. So in the amount of time it took us to understand what's going on, the data was replicated, read from the journals on the IBMI system, and written to our Kafka topic. Now, in addition to that, what's also happening is our data sitting in Confluent Cloud is then going to be pushed over to Snowflake, which is also running on AWS. We have an SMT that is taking care of that work. And now if we go over to Snowflake and we click our query, we can also see that Maureen's account has made it to our Snowflake data warehouse. Now the bank will be able to accomplish all of the analytics and other use cases that they use the data in Snowflake for. And you can see that the data is replicated quickly and easily. So if we now go back to the Data Integrity Suite, I think you have a better understanding of how our customers' improved digital experience was powered by the Precisely Data Integrity Suite. Our integration pipeline quickly and easily picked up our data from our source IBMI system to our target Confluent system, and then moved that data ultimately to Snowflake, and where our cloud platforms, Confluent Cloud and Snowflake, all running on AWS, integrate seamlessly and easily within our applications. Thank you so much for spending a little time with me today, and I hope you make it a great day.
That was great, Rochelle. So I'm going to ask our other panelists here to come off of mute and on camera. And we are going to start with some of the panel questions. So, hey, Rochelle. Hey, Gagan.
Hey.
That was a really wonderful product demo, Rochelle. It was great to be able to see what it looks like actually building a solution like that in the product. So can you tell me a little bit about how you guys have helped customers with this kind of use case in the past, and what happened? What were the results?
Sure, I can start there. So we've worked with a number of banks that are looking to improve their digital experience, their digital footprint, and many banks struggle with data being locked away in legacy systems, making it really difficult for their internal customers as well as their external end user and customers to be able to access that data in real time. And customers really want the data they need when they need it. And today, that's not just a want, but it's really an expectation. I want to be able to log into my digital portal, my mobile app, my browser application, and expect to be able to see and do all of the things at my fingertips. And without capabilities and solutions like change data capture to be able to capture the data from the source data and pushing it over to applications that power those modern applications. Those type of customer experiences are just not difficult or even impossible.
And Gagan, do you have anything to add?
Yeah, I think Rochelle covered it pretty well, but I'd still like to add maybe just very focus on a couple of things because in past decade or so, we have helped multiple banks in North America and external regions. We have helped multiple banks set up low latency, highly efficient replication systems. And what happens with this is because you're moving your data from legacy system, not just IBMI, it could be mainframes, EOS, vSAM data files. So a lot of other legacy data which is logged in there. Move that over to new age technologies like AWS, Snowflake sitting on it, Kafka. So what happens with this is now when you unlock this data, it opens up the data for the new use cases, the things which are not possible in past because the data was really sitting inside the mainframe. MIPS were really important. You can't run heavy loads on the mainframe for analytical systems. The moment you start to drive the information out from there and feed them into the other systems, it's open to the world. It's open to the business users. They can run analytics on top of it, and that's why now we are seeing this trend of my ML, my machine learning tool. It wants this sort of data set, which can be coming from mainframe, which could be coming from some other places, and all of that normalization starts to happen. So obviously, it gives you better value for your data.
Okay. And obviously, we've seen how this can apply to a banking use case, but what about industries outside of banking?
I'll take it. Yeah, so I mean, it's not limited to banking. It's not limited to insurance. It's everywhere. So you talk about, let's say, retail sector. Talk about, let's say, Starbucks or Walmart. Or let's say when you walk up to the point of sale for the billing counter, the aisle which is leading to that point of sale, what things need to be stacked up there so that people can browse them, can pick them. So what's really happening is these companies, they're analyzing their customer spend. What transactions are actually giving them more profit? What transactions are not giving them more profit? What locations are more profitable? What locations are less profitable? All of that is again happening based on the transaction. So when you swipe a card, those transactions get logged into mainframe. Typically, for the most part, talk about all the cards, Visa, Mastercard, everybody, they use mainframe. So everything is getting logged into mainframe. From the mainframe, when it is channeled over to the different platform, over there, this analytics can happen. What is the demographic? Which demographic wants what kind of data? What kind of service needs to be created for those categories of customer? So those customized services can be offered much better, not just in banking, in retail, pretty much everywhere.
Yeah, I think those are some really excellent points, Gagan. And one thing you mentioned, you touched on briefly, but I just want to bring out our retail organizations. So in
Yeah,
addition to standing in front of the point of sale credit card, seconds feel like hours when you swipe your card.
happens
Same
all the
thing
time.
for yeah, exactly. Same thing for retail organizations. Let's say I'm working on a project, a home improvement project, and I'm missing something. I bring up my local store inventory. I see they have it. I zip over there only to sadly be disappointed that they don't have it on the shelf. And all of that information is powered by mainframe applications. Often those large retailers keep those inventories on the mainframe. So if they're not updating what their customers see on their mobile apps, on their shopping apps, then it leads to poor experiences, which of course nobody wants.
Yeah, I actually had that happen to me recently when I went to a craft store to pick up something. So it can be extremely frustrating. And I think that, again, it kind of speaks to what we were talking about earlier with the fact that, like, customers have such high expectations. And now brands have to be very, very conscious of every single interaction that they have with a customer so that they don't possibly like lose them. Um, so I want to talk a little bit more about modernization and how that relates to AWS, because obviously it's very important that you have the same data existing across all of your platforms within your IT environment. So could you guys give me some do's and don'ts when it comes to modernization with AWS?
Sure, I can start there. So I think one of the really big, like top of mind do's and don'ts is don't try to boil the ocean. Don't try and do your entire project in one go. Those are the projects that often don't go well. Instead, think about, you have to understand the whole project, but then if you break up the project into smaller sub projects, the likelihood of success is much, much greater. And when you first look at like the whole ecosystem on a mainframe or IBMI system that's powering your business, your application, it does seem overwhelming often, but when you start then breaking that down into small projects, then you can start to move a little at a time, get some small success, leverage on that success, and slowly but surely be successful in migrating the data and the applications that you're looking to achieve.
Yeah, and many times it's not just one project. There's whole laundry list of projects using the same mainframe data. So you may have multiple applications using the same data set, and it's the little island of applications team which are created, and they won't even know that this is another application using the same data or enriching the same data. So that's another challenge a lot of times because it's hard to take on when you're talking about migration. There's really two things which come to my mind. One is just keep the lights on. The systems which are running on the mainframe, they will keep running on the mainframe. But then you add on these cloud systems to it so that you can now build new analytics on top of it. What it really means is the applications will run just the way they were running, but then the data gets replicated over. So it's just the data movement which we are talking about in this particular case. So that analytics can happen. And we are actually seeing this. A lot of times customers do that along with they would get something from the ERP system or some other data warehouse systems. They will rationalize all of that data sets, feed them to the analytical system. The output goes back into the mainframe. There's a reverse trend as well, where the output actually goes back into the mainframe because that's where the actual applications are running off. So that happens, and then even the mainframe applications get advantage from the analytics which are happening outside the mainframe. So that's really one thing. But then the other thing which Rochelle touched upon was the moving the application, which is a bigger task, and it may not be just 1 year; it can be multi-year project in itself, and that's where the challenges creep in because now you're talking about moving the application as well as its data requirement, and you have to keep the application on both the sites running for. I mean, that's generally recommended to have it running for multiple. There has to be some kind of overlap time so that you don't fall into some rabbit hole and then revert back. So that's really one challenge. I think the other piece is when you talk about legacy data, and I belong to pre-sales, so I also see this when I speak with different customers. When you talk about legacy data, there's not a ton of, I'd say, expertise out there because those people who built the systems, they are close to retirement or they have retired, and that legacy has been passed on. So now the people who are actually managing it, they're just really managing it. A lot of times they don't know the data that really well. I mean, you would have copybooks, let's say for VSAM, for sequential data, for different things, but those copybooks could be notorious because those copybooks may have, let's say, packed decimals, fillers, and those fillers may mean something to one application, but those fillers may not mean maybe a complete gibberish to me. So it's really hard to figure out what is that copybook for which application, and how to really move the data. So I would say if there is an expertise in-house, use it. But if you don't have an expertise in-house, use the services where the services company like us who have been doing it, and we have a history of doing this for past 40, 50 years because this is a company which is really coming from, it's a 50 years old company or more. And we were born on mainframes. So we know how mainframes work. We know how copybooks work. We know how data is sitting on the mainframe. So that's really important here.
Yeah, that seems like a very big do, right? Making sure that whenever you are taking on these really big projects, that not only are you bringing it down, but you're engaging with the right people to make sure that, those projects stay on schedule, they stay on budget. But kind of speaking about that a little bit, I know you started to touch on it, Gagan, but I'm curious as to what are some of the common customer challenges that you guys encounter when you're out working on this with organizations.
So if you come to think of it, because you're talking about the mainframe data set, and then there's two set of armies. One is you have a mainframe champion who you can't beat it. You ask him, he knows in and out of how this is working, where things are sitting. Here's a copybook, here's a PL program, whatever. But then there's another set of people who know nothing about it, or maybe they have a limited or even no access to mainframe. They do not know how the AppSedic, what is this AppSedic? Is it, they don't know it, and but they do require this data. So you're dealing with two different set of people, and and the challenge is you need to bridge them. You need to bridge them because the mainframe needs to speak with this new age systems. That means either the mainframe expertise need to know about the cloud systems, or the cloud system guys need to know about the mainframe systems. So understanding both the sides of the pipeline is really challenging a lot of times. Understanding the connectivities, it could be passing through different hoops, not a direct connectivity a lot of times because you have VPN and beyond that, whatnot, all of those things built into the system. So having that connectivity itself going back into the ZOS mainframe system or the IPMI systems also can pose a lot of challenges. So that's where challenges creep in. In addition, I had touched upon the challenges around the understanding the data set itself. Copybooks can be this little, one page, or copybook could be 50 pages. You don't know. I mean, when you see the problem, oh, I have 50-page copybook, and there could be one little thing, one little dot, or one little thing sitting somewhere in the middle of all these lines in 50 pages copybook, which will just throw you completely off. So mapping of that copybook with the data, when you overlay the copybook on the data, is it really making sense? Is it really unpacking those decimals? Is it doing that? Binaries? So that becomes a challenge.
Yeah, those are some good points, Guggen, and I think you've touched on a number of the technical points that customers can be concerned about or challenged by when looking at the data. But then we also see business challenges as well. The business users just want all of those things to just happen seamlessly, smoothly, and easily, which, as you just pointed out, are not easy things to handle. But they just want access to the data that they need when they need it. And so setting up the data in a way that makes sense for the business users to support their use cases, to support their analytics capability, their data science work, any AI work that they're doing with that data is critical as well. And of course, it all boils down to, did I understand the data in the very beginning?
Absolutely. And I actually want to dive into this topic a little bit more because I feel like a lot of times these use cases used to be very, very technical in nature, but now we're seeing more and more business users are wanting to, get in with the data. They're trying to use it for things outside of just these really technical use cases around just moving it specifically. So can we talk a little bit more about just business users and what they're looking for and how that kind of relates to what we're talking about now?
Sure. So, yeah, I think, many times all of the data, once you have your process set up so that you can access all of the data in your enterprise to support the business needs, the business users do expect that all of that data is together and don't always or maybe make some higher level assumptions that everything they need to support their data science work and AI work is there. So it's really critical that when we think about bringing together the all of the data from within all of the enterprise applications, we focus on the all. That it's not just the data that's easy to access, but it's all of the data, some easy, some not so easy, to make sure that we're making good decisions based on complete and accurate data.
Yeah, I think So if you look at the history of how this has evolved from mainframe, and then originally there was this era of going into from mainframe to data warehouse, and then came MapReduce and Spark, and now we talk about cloud storage and cloud compute and Snowflake and delta tables, right? So there's a whole evolution, and why that evolution basically? Because the whole reason is business users obviously are demanding more and more, obviously, right? So now I categorize users into three categories, and it's not business, it's not industry standard, it's just my categorization. That's how I classify people. There's IT, or we sometimes people call plumbers, which is really moving the data from mainframe, other legacy system, or even non-mainframe data set into a location which can be more consumable, because those areas are either locked in, you don't have access to it, either a public-private key pair won't work or something won't work, and then you can't get access to those data sets. For the people who don't have access to those data sets, but they know they do need data for their work. Those are the operational people, because they understand data, but they just can't get to the data. They also understand the business requirement. If a financial analyst walk in, hey, give me the so wealth management, for instance. So how much was the investment done by whatever high net individual, and what is the portfolio distribution of so and so forth, let's say. And so conversion of that whole business requirement into something which needs to be mapped to this table and this column of this data set. Maybe it's sitting in IBMI, maybe it's sitting in Oracle system, maybe it's sitting somewhere else. That goes back into different 2 or 3 branches, pulling all of those data sets together, creating a single view of it, and then creating the report out so that can be fed to the financial analyst. And then he can further talk to his high wealth management customer that this is the right investment for you, another opportunity coming up. So that whole chain becomes really important. So it really has to pass 3 things, which is the plumbing, which is the IT, pure play IT. And within the pure play IT, obviously there's layers of security and other compliance things. But then you have the operations, who is kind of bridging this IT as well as the business language. And then comes the real consumer, who is consuming this data set and actually making those business decision protocols. So the consumption is actually increasing, because it's not slowing down. It's increasing day by day. You are now going from standard consumable. I think 10 years back, we used to talk a lot about self-serve, what it meant and there were different concepts. So there was data virtualization, or you bring in the data and don't virtualize, because virtualization can really slow you down. So you bring in the data in a single repository, and then the business users or the operational users, they can actually query and just have a self-serve dashboard kind of thing. But now you're talking about AI, ML models, which are dynamic. Now the fact that they are dynamic, they also need dynamic data. That means now they're looking for more real-time data to be fed into it, so that now when a customer is actually on the browser and it's making certain decisions to buy based on the browsing history, based on what is already in the shopping cart, you can throw in the personalized recommendations. You throw in the reviews, you throw in the recommendations, you throw in the expertise, expert reviews, all of those things. So that comes flying. I mean, it's not predetermined. It's happening on the fly. So this consumption is actually increasing, and then it's only going to increase.
So I think that actually, oh, sorry, go ahead, Rochelle. Oh, okay. Well, I think that brings up a really good point, though. Like the fact that the consumption is increasing means that it's even more important to make sure that everything is running properly, right? So, what are some practical strategies for doing things like minimizing downtime or things like disruptive modernization while companies are in the process of moving data from a mainframe or an IBMI or some similar source to the cloud like AWS?
Yeah, I think to me, when we talk about minimizing downtime, um, what it really means is, what's your business objective? Are you trying to replicate the data to actually feed to some AI model? and which requires certain thing in it by a certain SLA, by a certain time frame? Or are we okay with guaranteed delivery, but it could be a second late, it could be a minute late, it could be a 10 minutes late. It's okay. Ultimately, the model is fed with that information, and then there's a batch process which is running, which is feeding into it. It consumes it, and then whatever work it needs to do that, it can do that. So I think SLAs are what is the business objective versus if there is something which is more real-time requirement. So we need to understand that. And once we understand what is the real requirement for the data movement, we can build an architecture on it. Otherwise, there's really no point giving a real-time architecture or a sub-second SLA if it's not worth it, because there's cost to it. You are setting up parallelism, you're setting up the different, I'd say, pipelines and projects to understand this data movement, and data needs to move in a second or a 2 second or a 5 second SLA, only to be consumed by a service which doesn't maybe require it. So I think understanding that, and if you have, let's say, multiple systems on the right side, that means on the consuming side, do I feed directly into those? Or do I feed to a more like a messaging system? So you can have MSK or Confluent Kafka. So that's sitting in the middle. So you feed to the messaging service, and then that messaging service can further connect to 5 different applications. So now you get the same view of data, same data, and then you are managing really just one replication instead of managing 5 different applications. So really understanding the architecture, really understanding the use of the data or the multiple usage of data, that's really important, because otherwise you just start without knowing that can be a real challenge. That can be, you may not end up anywhere.
Yeah, I think that's a really good point. When you don't understand the use case, when you don't understand what it is you're looking to achieve, kind of the idea of where you're going, then how do you know exactly how to solve those problems, or how do you know when you've completed it, or when you've reached your destination? So it's so important to really step back, understand the use case, understand who's using the data, what data they need, and why they need that data, and how quickly they need that data. To your point, Gagan, if you don't need the data very quickly, then then pushing the data real time is overkill in a sense. And conversely, if you do need the data instantaneously and you don't get it fast enough, then that can result in very poor experiences, risk for the business, fraud going undetected, all sorts of undesirable results.
So I have one more question for you guys before we jump to the audience Q&A. But I'm kind of curious about, like, we've spent a lot of time obviously talking about integration. That's what you guys are experts in. But I'm a little bit curious about some of the other stages of the data lifecycle or data considerations that an organization would have. For example, things like security or governance, being able to keep up with compliance, things like that.
Yeah, I can start there. I think that it's super important to ensure that you have the right data at the right time. But when you think about the right data, you also need to be concerned about, or make sure that the data that you're using is the governed data. And that when you move data, let's say that you make some decisions. Maybe you don't understand the use case entirely, and you don't realize that there are multiple different sources for the same data, and don't select the governed data or the data that's been approved by governance in your organization, then of course that's another example of where the results are going to be less than optimal. And then also taking into consideration things like security and compliance. Today there's so much focus on compliance, making sure that the right data is only visible to the right kind of people. PII data is hidden away from those who don't need to see it, and all sorts of examples of compliance based on the different industry that we're focusing on. So, kind of, I think the lesson there is make sure that when you're putting your project plan together and focusing in on your use case, don't forget about governance. Don't forget about things like compliance and security, because they're going to be a lot easier to address in the beginning of the project than they are as oops, now what do we do about those?
Right. To me, data movement or the data replication, nobody's is doing it for the fun of it. There's obviously a rationale behind it. There's obviously a business use case, right? So the business use case is never, oh, I want to move this data from place A to place B. That's never a business use case. There is a bigger business use case out there that I want to do transactional analysis to find out who is my, I'm just obviously phrasing an example here, who are my best 10 customers who I can go after, my sales rep can go after them, for instance. So there's a use case why you need certain data set. When we talk about this replication pipeline in the projects, that's serving just the data availability requirement of it. That means now you make it consumable and ready for that business use case. It's serving up that use case. Once that, so it's really a starting point for most of the people, most of the business community. Make it available to me. And from that point onwards, once the data is unlocked from legacy system and from other ERP systems, it gets unlocked and it's available and consumable for this business society. Then on top of it, now you're talking about different things on top of it. You're talking about, let's say, enriching data. If I have a customer house number and everything, so now you may want to have till a rooftop longitude latitude information of where the customer is actually residing. And based on that, what is a heat map and how many such people in the same geography reside there? So maybe that information is useful. So you start to enrich that data set. Or if you talk about the company's data, you add, let's say, Dun and Bradstreet ID, and that unlocks, oh, this company does work with this different partners. It has this and these vendors, and these vendors further have another business relations. So now you unlock this entire chain of what's the connectivity. So those are the real use cases where now once you have the data, you enrich it. But even before you enrich it, you want to make sure the data is clean. That means now you're talking about data quality. That means now you're talking about creating certain rules. Those rules can be predetermined. Those rules can be dynamic. You can also put a threshold on top of it that this is my quality level. And if it comes below that, I'm going to say this is a junk data to me. I'm not going to use it, right? So you set up those thresholds, you set up those quality pipelines, you do those checks and balances on the data, and then you make sure the data is correct. The other thing is now it has to comply to the data structures of the consuming society. So if it's coming from different locations, those data sets could be talking in different languages. Oh, it's a dollar value over there. That's a pound or something else. It's millimeter over here, and it's kilometer over there. So it's different languages. Now it has to comply to one language. That means now you're talking about putting a business context on top of data so that all of these different data sets, they talk same language, because otherwise these are numbers and nobody would know what that number is. Is it am I measuring my milk in ml or is it something else? I don't know. I mean, in ounce. So I don't know. I mean, unless there's some kind of a business taxonomy attached to it. So obviously, once the data movement happens, then it opens up all of these areas where you have this quality coming in, where you have this enrichment coming in, where you have this governance coming in. All along, this has to be presided over by, I would say, access control. Because let's say if you are moving up PII data, it's not fun if somebody can come and sue you, right? So you have to be really careful about how you are moving the data, where you are storing the data. It has to be within your systems, and obviously there are restrictions around your systems of who can access it. So the access controls become important. So all of those things, when they come together, that makes a business use case. So, and I think Rochelle touched upon in the initial part of her demo where she showed up the the suite screen. And although we focus just a small part of it, which is just the DI, but beyond DI, when you set up those connections, that means now you start to catalog those connections. What you really mean is when you catalog those connections, now I can understand it has these many libraries and these many tables and columns and what's the primary key. And then there's another connection coming, there's another connection coming in. Once you have these 5, 6 catalogs, I can build my data governance on top of those catalogs. And then those catalogs are connected. Now these catalogs are talking to each other. So that's really important. And again, in a lot of cases, this master data management becomes really important. What it means is I have this customer information coming in, but that customer is his primary residence is in some location. He has some investments in certain other location. How is that related? So can I attach those different addresses to the same customer? So to create a one big record, that's master data management to me, right? So you are really combining multiple points into one point, and then it becomes a golden record that can be fit into the systems. So all of those things become really important. It's a cohesiveness of all these different modules or the attributes, which really makes up the use cases. I'll stop here.
Yeah, I mean, it sounds like there's a lot of considerations that organizations need to have before they go, jumping into an integration use case because there's a lot more to it than just the data movement. Um, this was a great panel. It's been really wonderful interviewing you guys. We do have a bunch of questions. I don't know if we're going to be able to get to all of them, but we are going to do our best. And again, if we don't get to your question, we will follow up with you after the session. So let's just dive right in. First question is, can you share how replication would work for an IMS database?
Yeah. So yeah, we replicate from IMS database. So the way it works is IMS is sitting on your COS systems. It's a little different interface what was shown in the demo. So that's a little different. What happens is you have a configuration on the uh, mainframe side as well. So you have the jobs which we kick off on the mainframe side. And typically IMS would write to the log stream, kick stream, CICS. So our watchers on the they would sit on the mainframe and they would watch those log stream. So any change in the IMS record will be written out by IMS into that log stream, and our watcher will read from that log stream. Now, what we also do is we create a small metabase, what we call metabase. It's really a library which we create on the mainframe that stores that information. So now once the logs are read, and if logs are removed, because logs can grow heavy very quickly, your IMS is changing or your other things are changing and it's producing a lot of churn. And then those logs would be archived. Those logs can be archived to tapes, and it happens all the time on the mainframe. So now reading off the tape is challenging, it's time consuming, and it's WIPs consuming. So what you really want to do is you want to read that change as soon as it's available, which is what we do in a very lighter way, and then we put it in our queues. So those queues, they are dynamic in nature because then you have this pipeline running from IMS or the ZOS into wherever you want in the right side, SQL Server, Oracle, AWS, anything, right? So it has this acknowledgement mechanism. So what we do is once the data is in the queue, it establishes a connection, which is already there, actually. It contacts the right side, which is the target. It transfers the data, and it sends the acknowledgement back. Once it receives the acknowledgement, it will remove that data from the queue. So the queue management and everything is asynchronous and automatic. But the advantage is you get this guaranteed delivery because you're doing this acknowledgement. You're also getting a very low overhead on the mainframe because we just read off the logs, and there's no real need to keep the logs till the time it's not read off. So yeah, I mean, we do it all the time. IMS is one of the key areas which we tackle.
Okay. What about options for two-way data synchronization? For example, DB2 to SQL Server, and then back from SQL Server to DB2 if there's any changes in the data once it moves to that target.
We do that as well. So there's two ways you can do. One is you can have a two-way replication setup. And there can be certain edge areas where we may not serve up, but in general, I'll just throw out a couple of options here. There's two ways. One is you have two different pipelines set up. One pipeline is transporting from point A to point B. The other pipeline is transporting from point B to point A. And then you have you can always have an exclude list of so when you replicate, there's a replication ID which is attached to it. Okay. What it means is when I'm replicating the data and I have this replication ID, it identifies anything which is not put by the replication ID. What it means is when I go from point A to point B, it knows the replication ID has inserted or updated those records. So when I'm going back from point B to point A, it's not going to take the same data again because it knows that this data actually came from the replication rather than a new data, if it makes sense. And I can go on, and I think this question is from Pramod. So Pramod, if you want to chat about it later on, I can obviously explain this to you in more details. We are really at the top of the hour here. But that's really two-way replication which can be set up, or two different pipelines. If you want to stop the data, analyze it, and if at point B there's yet another set of systems which are running, and you want to just take the change back into the point A, that's also feasible.
Okay. And I'm going to try and squeeze one more question in here because we're almost right at time. But I think this kind of relates a little bit to the last question as well. So will the system of will the system of record update back in the DB2 as well? So I think that this, again, kind of ties to the reversing replication a little bit.
Which is right. I mean, and I think in one of your questions, I kind of answered that. I was touched upon that. I touched that. We are seeing this evolution of reverse replication is what we call. That means now you have this information which we were transporting from mainframe or other systems into the cloud, but after that you do some analysis work on the cloud or the Kafka, and then you push it back to the original systems. So those are things which we are doing. Absolutely.
Okay. Thank you so much, both Gagan and Rochelle. We do have a couple more questions left, but I don't think we're going to be able to finish them in the 30 seconds or so that we have left in this session. So I did just want to say a quick thank you again to Gagan and Rochelle for being excellent technical experts, as well as everybody who was able to attend this session. We're so excited that you guys were able to be here with us today, and we hope that you have a great rest of your day. Thanks all.
Thank you. It's our pleasure. Thank you.